Hello everyone, Assalamu alaikum. I am Asaf Muntakim. Today I would like to present our project titled Predicting Digital Dependency Score from Digital Habits and Mental Health Matrices using Machine Learning. Today I am going to show you how in this modern digital era technology has become deeply integrated in our daily lives. Smartphones, social media platforms, and digital applications offer convenience and connectivity, but excessive uses can negatively affect mental well being. Issues such as anxiety, depression, poor sleep quality, and reduced productivity are increasingly being linked to prolonged digital engagement. The objective of our project is to predict an individual's digital dependency score using machine learning techniques. We analyze a wide range of factors, including demographic information, digital usage patterns, and psychological health indicators, etc. These features together help us understand how digital habits influence mental health and overall well being. Traditional statistical methods often struggle to model complex and high dimensional behavioral data. Machine learning, however, provides more robust solutions by identifying hidden patterns and relationships within the data. In this project, we focus on regression-based machine learning models to predict a continuous target variable, the digital dependency score, and compare different algorithms to evaluate their effectiveness. Our study aims not only to achieve high prediction accuracy but also to maintain interpretability, which is essential for real world applications in mental health assessment and digital well being monitoring. Now, I would like to briefly discuss the existing research that inspired and guided our work. Number one is digital phenotyping and behavioral biomarkers. Recent studies emphasize the concept of digital phenotyping, which refers to the analysis of digital footprints such as phone usage patterns to assess mental health conditions. Research shows that passive sensing data, including app users, frequency, and phone unlock behavior, can effectively predict mood changes and psychological states. Chickersell and colleagues demonstrated that phone unlock frequency is often a stronger indicator of mental health status than total screen time. This finding supports our decision to include habit-based digital matrices as key predictors in estimating digital dependencies. The next model is the multimodal data in mental health prediction. Another important area of research focuses on the integration of multimodal data, combining psychological assessment with lifestyle and socioeconomic factors. Studies have shown that machine learning models trained on diverse data sources such as income level, daily routines, and mental health scores are highly effective in identifying anxiety and depression risks. These findings influenced our approach of using holistic feature set, combining demographic, behavioral, and mental health indicators to capture a complete picture of digital dependency and well-being. Next, we'll talk about model performance and interpretability in mental health in machine learning. Previous research highlights a major challenge in mental health machine learning, balancing accuracy and interpretability. While complex models like neural networks can achieve high accuracy, they often behave as black boxes, making it difficult to explain predictions. Uh, Several studies emphasize the importance of explainable and interpretable models, especially in clinical or psychological applications. Interestingly, research shows that when relationships between features are strongly linear, simple models like linear regression and Bayesian methods can outperform complex models while remaining transparent and trustworthy. This insight aligns closely with our project where we evaluate both traditional and advanced machine learning models to determine which best captures the relationship between digital habits and mental health outcomes. To summarize, existing research shows that digital behavioral patterns are strongly linked to mental health conditions. Prior studies on digital phenotyping, multimodal data integration, and model interpretability strongly support our approach of using machine learning to predict digital dependency in a reliable and explainable way. In the next part of our presentation, my friend Vega will talk about the foundation of applying these concepts to our dataset and evaluating different machine learning models. Thank you.
Hello everyone, today I want to show you how we use machine learning to predict a person's digital dependency score. We used a dataset of 3,500 people. To make our prediction, we looked at several specific pieces of data. For example, for digital habit, this includes daily phone unlocks, notification and social media minutes. For mental health, we looked at anxiety scores, depression scores and sleep quality. And for demographics, we looked at age, job and income. While our main target was digital dependency score, we also tested if we could predict happiness and phone unlock scores using the same numbers. Now for methodology part, we used one hot encoding. Since computers only understand numbers, we use this to turn our categories like region or job into ones and zeros. Secondly, Secondly, we use standard scaler for feature scaling. In our data, notifications might be huge number like 500 while anxiety is a small number like 10. Scaling shrinks all these numbers down so they are on the same playing field. Now, lastly, we did an 80-20 train and test split. We used 80% of the data to teach the models and kept 20% hidden to test how well they actually work. Now, lastly, for model implementation, first we use random forest. This model builds 100 different decision trees and takes the average of their guesses. It performed very well with an R2 score of 0.955. Next comes AdaBoost. It runs simple models and focuses on fixing the mistakes of the previous one. It achieved an R2 score of 0.904. Next comes K-nearest neighbor or KNN. This model looks at the 5 most similar people to make a guess. It had the lowest performance from all our models of R2 score of 0.716. Next comes MLP. This is a neural network with hidden layer of 100 neurons and railway activation. It performed strongly with an R2 score of 0.959. Next is the Bayesian bridge. This is a probabilistic model that is very good at handling noisy data. It matched our top performance with an R2 score of 0.9859. And last but not the least, our best performer was linear regression. This model uses the OLS method to find the straight line relationship. This was ultimately our top performer with an R2 score of 0.986. By comparing these 6 models, we proved that digital addiction is highly predictable, especially when using linear and probabilistic methods. Thank you.
Thank you, Asaf Muntakim and Zarin Tasnim, for go through the introduction, literature review, methodology, and machine learning models. Now, I will present in front of you the result and discussion, and finally the conclusion. The results were quite surprising. We initially expected a complex machine learning model to dominate, but the data showed otherwise. Linear regression was the top performer. It achieved a remarkable 98.6%. The Bayesian rigid model followed closely, matching the performance. The black box models. While the multi-layer Perceptron, MLP, and random forest perform well around 95 to 96%. They did not beat the simpler learning linear models. KNN performed the poorest as roughly 71.6%. This happened because our data became too disparate after encoding categorical features, causing the course of dimensionality. As you can see here in this table. Discussion. So, why did the simpler linear regression win? The answer lies in the linear relationship of our data. We found that mental health indicators like anxiety and depression and digital habits, especially phone unlocks, have a direct proportional link to digital dependency. As anxiety rises, dependency rises in a straight line. This finding is crucial for real world application. Complex neural networks are often making them hard to interrupt. However, our linear model is transparent. A clinic, a clinician can look at the result and clearly see how reducing a specific behavior, like the daily phone unlocks, will directly lower a patient's dependency scores. Now, finally, the conclusion. To conclude, our study proves that digital dependency can be quantified with 98.6% accuracy. We identified that the frequency of engagement is a stranger predictor of dependency than total usage time. Moving forward, we plan to expand this research by incorporating time series data. This will allow us to move beyond a static snapshot and analyze how digital dependency evolves over months or years. Thank you. That's all from us.